Hey, welcome to the Witcher Math channel. You can see what we're talking about today. Rational numbers, multiplying and dividing, positive and negative values. And that's it. We're keeping it simple, hopefully keeping it short for your viewing pleasure and for learning. Brought to you today by the color red and green and by Mr. Calculator. Okay. First of all, let's talk about the signs. And by signs, I mean positive and negative, not to be confused with adding and subtracting. Okay? Trouble people still have these days, and I think still will into the future, unless you watch this video, which will solve all of your life problems, is when we're multiplying. I'm going to use the dot for multiplying, or dividing. Fraction bar is the same as division sign. The X and the dot. All the different things that mean multiply and divide. As you could imagine, leads to a bunch of different rules and lots of confusion among learners. And I like to make that simple and just say that if they have the same sign, let's summarize this with one rule. My list of rules right here. Same sign, positive answer. Answer, result, whatever you want to call it. Product, quotient. All the words, bottom line is just use the word answer and it kind of covers all of them. If they have the same sign, the answer is going to be positive. That's it. Learn that rule. Here's some examples. What if I have a positive integer divided by a negative integer? Is that answer going to be positive or negative? Right, negative. Why? Because they don't have the same sign, so they don't have a positive answer. That's called the converse is true. Not the shoes, but the opposite of the opposite of the rule is also true. The converse. Okay. What if I have a negative decimal times a negative fraction? What will the sign of the answer be? Do they have the same sign? Yes, and if you're nodding your head up and down, that's a positive response to my question, right? So just like the positive answer will be. If you're nodding your head yes, yes equals positive, and shaking your head, so your nod goes up and down your head. And if you're shaking your head back and forth, left and right, that's a negative response. Okay, let's keep that in mind as we do a couple more examples. These are all rational numbers. Rational numbers are integers, fractions, and decimals, basically. Let's keep it simple. If I have a positive decimal times a negative fraction, do they have the same sign? Shaking your head, no. And look, my pen's going that way too. Makes me want to make a negative sign. It's that easy, okay? What if I have a negative integer divided by a negative decimal? I see you out there. Same sign? Yes. Up and down, nodding your head. Yes, there you are. A little bit of hair there. So, positive. Good. That's all we need to do to talk about all the rules. All of the rules. Let me highlight all of them. This will take so long. Highlight all of the rules for multiplying and dividing rational numbers, both positive and negative. Okay? Boom. If they have the same sign, you know what the answer is going to be. If they don't, you know what the answer is going to be. And the converse is true. That means if they don't, it won't. Okay. Keep that in mind. Hope you got those. If you didn't, just back up the video and take a screenshot. Those are beautiful notes. Next, we go to, since we don't have to worry about signs anymore, we're going to talk about actually do the operations, which doesn't mean go to school for 10 years and become a doctor. It just means multiply or divide. And we're going to find all the different combinations. So fractions, decimals, integers, signs, see the last page. We're not going to worry about them now because we have a strategy. And multiply, divide. So for example, if I'm going to do a fraction, let's do a decimal times a fraction. Choices. This is also very troubling for students. Sometimes we got to choose. Do I want this to be a fraction problem or a decimal problem? Either way, I have to change one of these things to the other thing. So let's choose to make it a fraction problem. I'll show you both examples. If I've got, let's do 3/10 there and 3/4. How do you say this decimal? How do you say that the right way? No, not 0.3. Say it the proper way. Right, it's 3/10 times. Now it's a fraction times a fraction, which is lovely because we just multiply the numerators. 3 times 3 is 9. And multiply the denominators. Straight across. We don't need anything common. That's for adding and subtracting, not for multiplying and dividing. So in some ways this is actually simpler than adding and subtracting fractions. So 9/40 if we make it into a fraction problem. Let's say we love our little decimals and we love calculators. So let's use it. Turn this into a decimal problem. Do you know that if you use a calculator, you can change this by hitting these buttons in this order? Numerator divided by denominator. In this case, 3 divided by 4, and you'd be staring at that. So there's our decimal. We changed 3/4 to a decimal. And then we just multiply that straight across, or whatever, straight across, or whichever direction you're holding your calculator. Okay. And we get this, 225 thousandths. That's a 2. And you might think, oh, that's kind of weird. I don't believe that. So go up here to your fraction. Let's check it out. If we grab the calculator and go 9 divided by 4t, 9 divided by 40, and guess what we get? Yeah, you knew because it's a video and I'm not going to do it over. Okay, so we get the same answer either way. So it all comes down to you got to make a choice. And that choice might be different on different problems. Some fractions you might already know what they are as decimals. And some decimals, if you say them correctly, they just make fractions automatically. Let's do one more example. Let's do division. Let's do a fraction divided by a decimal. Once again, I refer back to the first half of the video. We don't care about the sign because we have a strategy for that. So we're just going to talk about the rational number division in this case. I'm going to take 3/4 and divide it by this decimal. Out on the streets, the kids like to say 0.2, but in math class, we don't. We say something more mathy. So just like up above, let's make this into a decimal problem. And since we're paying attention to our own work, we already know what 3/4, 3 divided by 4 is as a decimal. So let's use that knowledge right here. And we already know what 0.2 is. That's a joke. So straight up on a calculator, very nice. That is my result. So in this case, since we already knew what the fraction was as a decimal, maybe it makes sense to do the whole problem as a decimal problem. But since we also know how to say this in a different way than 0.2, we could make this into a fraction problem. How do you say that? Yeah, 2/10. I know we can simplify and do other stuff. I'm doing my best to keep this short. Here's a strategy I call flippin' multiply. Keeping my language clean, this actually is an evolution of flip-in multiply, which if we trace it back through ancestry.com, further becomes flip and multiply. And here's what I mean. They're fractions, we like that, but we really love fraction multiplication, so let's make them all look like that. So I'm going to multiply instead of divide, and here comes the flip. Got it? Flip and multiply. Or clean it up and say flip and multiply. Okay, so we're going to go straight across. 3 times 10. What is it? Yes. 4 times 2. Ocho. 38ths. Sure, we could simplify that, but here's what I want to do is I want to go ahead and calculator it, using calculator as a verb. So I've got 30 divided by 8. The reason I'm doing that is to see if it matches my decimal problem, proving that both strategies work just fine. It all comes down to you making a choice. Okay, so that's it. We're done. Rational numbers, multiply, divide, fractions, decimals, integers, choices. Make them all decimals or make them all fractions. Up to you. We should get the same answer either way. So make your own choices. I hope they're good ones. And thanks for watching. Goodbye. Oh yeah, subscribe. Bye.